you for joining us for tonight's program, Night of the Shooting Stars. I'd like to introduce you to Joe Rao.
Okay, well, hi everybody. As was just mentioned by Catherine, yes, my name is Joe Rao, and I'm going to be your host tonight. We're going to talk about a very special, potentially special astronomical event which will be taking place, we hope, in less than a couple of weeks, actually on the night of the 30th and 31st of May. Now, before we get into this, a couple of things I want to mention. Number one, from time to time, and this is a PowerPoint program, by the way, from time to time you'll hear me pause for a few moments because I'll be taking some sips of Poland spring water to lubricate my vocal cords, since I will be talking for the better part of the next hour. Also, if you have not already done so, I'd like to indicate to you that it would be great if you could mute yourself. I see a lot of you have already, but I'd like to have people mute, so this way we don't have any extraneous noise or sounds in the background while I'm talking that might actually throw me off a little bit on my presentation tonight. Tonight is the night when we'll talk about the Night of the Shooting Stars. And as this is going to be a PowerPoint program, I'm going to share my screen with all of you now. And we're going to be doing that. And as we do so, I'm going to get my slide up. Slideshow here. Turn my camera off. And away we go. As I said, this is a program about a possible new meteor shower. And if you would like more information after you hear my talk tonight, you might want to go down to your local bookstore or magazine outlet and see if you can get a copy of the May 2022 edition of Sky and Telescope magazine. And I've written a feature article which details everything about this shower. And in fact, most of what you're going to hear me talk about tonight is based upon this particular magazine article. So there you go. The story begins, and it's a rather compelling story, begins 92 years ago in May of 1930, when these two gentlemen, the gentleman on the left is Arnold Schwachmann, and the gentleman on the right is Arno Wachmann. And Schwachmann and Wachmann discovered a comet. Not anything new for them. These guys were the dynamic duo of Hamburg Observatory in the late 20s and early 30s, discovering not one but four different comets, three of them independently and one shared with an American amateur astronomer named Leslie Peltier. So this was the third that they discovered. So it was known as Comet Schwachmann-Wachmann 3. Now, I am not going to continue to call it Schwachmann-Wachmann 3. Instead, I'm going to do a little bit of shorthand and call it simply SW3. So when I talk about SW3, it's the comet that these two guys discovered again in May of 1930. Now, after enough observations were made for astronomers to calculate an orbit for this new comet, a very interesting piece of information came out. This comet was going to pass very close to the Earth. In fact, the distance would be, on May 31st, 5,735,400 miles away. Now, if a comet is going to come that close to the Earth, usually, it either becomes a spectacular sight in the sky or at the very least, a very interesting sight in the sky. Well, that was what everybody was thinking when the announcement was made that SW3 was going to pass this close to the Earth, less than 6 million miles away, at the end of May 1930. And I'm going to give you two examples of what happens when comets come very close to the Earth. Here is one example. Almost 40 years ago, in 1983, a comet by the name of Iris-Araki-Alcock swept to within 2.9 million miles of the Earth. Second closest approach to the Earth ever in modern times. There was one in 1770 that passed only 1.5 million miles away. This comet, Iris-Araki-Alcock, in 1983, was not a spectacular object, but it did manage to get up to the brightness of the North Star, Polaris. It did not develop a tail, but it looked like kind of a fuzzy ball of light, which over a span of a few nights went from one end of the sky to the other. I watched this comet, and it was interesting. when you look at normally when you look at a comet in a telescope, you see the tail and the head, and you see maybe a few background stars. This comet came so close to us in 1983 that you could actually see it move next to the background stars. It was moving very slowly. It was almost like watching the minute hand of a clock, but you could see it moving because, again, it was coming very close to the Earth, 2.9 million miles away. So not a spectacular comet, but certainly an interesting comet. Okay, then let's take a look at another comet 13 years later in June of 1996. This comet, Comet Hyakutake. Now, this comet was discovered by a Japanese observer in February of 1996, and in the latter part of March, the comet came within 9 million miles of the Earth. Not as close as Iris-Araki-Alcock, but it certainly made up for that because it was a larger comet, and it was, as we say, more intrinsically bright. There was a lot more volatility involved with the comet, so it became much brighter and more noticeable in the sky than Iris-Araki-Alcock. And in fact, on the night when the comet was passing closest to the Earth, at the time I was living in Levittown, Long Island, and my best friend was located in North Merrick, Long Island, and I called him up on the phone. I said, we ought to get away from Long Island. Sadly, Long Island is not what it used to be. 50 years ago, there were, especially out in the eastern part of Long Island, you could go out there, the sky was absolutely black. Light pollution has taken away a goodly amount of the sky. We don't see the stars as clearly and as brilliantly as what we used to see many, many years ago. With that in mind, I told my friend, why don't we travel somewhere where it's still dark? Why don't we go up to Dutchess County? And we did. We got into my minivan and we drove a couple of hours north of New York City up to the community of Hopewell Junction in Dutchess County, New York. It was like 1:30 in the morning. We finally came to a residential site. I parked the van. We both opened up our doors, respective doors. We looked up and we saw the comet. We saw Hyakutake with a head far brighter than the North Star, what we call a zero magnitude, and a tail that stretched across the sky for 40 degrees. Now, 40 degrees would take the tail halfway almost across the sky. What an amazing sight. We stepped outside, we looked up, we see this comet, and I said to my friend, well, this isn't something you normally see on most nights. This is something you don't see every day of the week. This was Comet Hyakutake, and indeed, as Sky and Telescope's cover story mentioned, it was indeed a hit. Here is an interesting photograph that was taken from Midtown Manhattan, from 29th Street and Avenue of the Americas. And you see here, of course, you recognize the upper spire of the Empire State Building. And look, right next to the Empire State Building was this little fuzzy blotch. You know what that is? That was Comet Hyakutake. Now you couldn't see the tail, of course, because New York is one of the most light polluted cities in America, if not in the world. And yet, through all of that light, you still were able to at least see the bright coma or head of Hyakutake. And again, this person on Avenue of the Americas and 29th Street able to photograph this comet right next to the spire of the Empire State Building. Amazing. That shows you how bright this comet was. And it was bright because, again, it came very close to the Earth, less than 10 million miles away. Well, now, getting back to SW3, in May of 1930, this comet was coming less than 6 million miles away. So a surge of excitement. Will it get very bright? Will it be spectacular? Will we see a long, striking tail in the sky? Will it be at least interesting enough so that we could follow it with the eye from one end of the sky to the other, like we did with Iris-Araki-Alcock many years later? But no. Look at Comet SW3, Schwarzmann-Wachmann 3. It turned out to be a very tiny comet, tiny by the standards of most comets. Halley's Comet, for example, is about 8 or 10 miles wide, and Comet SW3 was just barely over 1 mile wide. So it was small, it was dim, and even though it came very close to the Earth in late 1930, May of 1930, you had to use binoculars, good binoculars to find it, and at the very least, a good telescope too. This was not a spectacular, nor to the average person, very interesting comet. But still, a comet is a comet, and it's coming very close to the Earth, and so observatories around the world trained their telescopes on it and tracked it as it moved past the Earth. This is the world famous, still famous, 40-inch refracting telescope at the Yerkes Observatory in Wisconsin. Still the largest refracting telescope. There are two types of telescopes. There's a reflecting telescope, which uses a giant mirror. The Palomar Observatory in California is 200 inches across and is one of the biggest. But the Yerkes refracting telescope is still the biggest refracting telescope. It had a lens 40 inches across. And on the staff of the Yerkes Observatory way back then was a gentleman by the name of George Van Beesbroek. He was an immigrant from Belgium. He came to the United States, and he had a particular interest in the small bodies of the solar system, meteoroids, asteroids, and yes, comets. So when a comet is coming as close as SW3 did, you could be sure that Van Beesbroek, known to his friends as Van B, you could be sure that Van B was going to have that telescope trained on it every clear night that month. And here he is. I always laugh when I see this, not so much. The reason I laugh is that, imagine having the biggest refracting telescope at your disposal on any particular night of the year that happened to be clear. And Van Beesbroek, or Van B, took many observations of the comet when it passed on by in 1930, took photographs of it. No, the comet was not 10 feet wide, as this photograph indicates. In fact, this scale indicates minutes of arc. So the comet subtended 2 weeks before it came closest to the Earth, at least 20 minutes of arc across. In other words, it had a coma or head that appeared about 2/3 the apparent size of the full moon. And when the comet came closest to the Earth on the last night of May in 1930, Van Beesbroek, with the Yerkes Observatory telescope, saw a tiny spindle-shaped object in the middle of the gaseous coma. He may have been one of the first people to actually see the nucleus of a comet using, again, the great telescope, the Yerkes Observatory telescope. So now May 31st comes and goes, and the comet goes back out into space. The comet has an orbit that takes it around the sun every 5.5 years, give or take a month or two. But after 1930, look at this. The comet was missing in action. These are all the dates, all the years that the comet came closest to the sun, but was never seen by amateur professional astronomers. And why is that? What caused that comet to remain unseen for half a century, mind you? You see all these dates here? The comet apparently swung around close to the sun. In 1979, hip, hip, hooray, we saw it briefly. And then in 1985, again, the comet was gone, missing. Why? Well, you already know one factor. This comet is very small, very dim, very faint, so hard to pick up in the first place, but also because of this big guy. This is Jupiter. This is the biggest planet in our solar system, measuring 11 times the size of our Earth, 1,300 times more massive than our Earth, the biggest planet in the solar system, so big, in fact, that if we were to roll all the other planets together in one big lump, it still would not match the massiveness, the weight of Jupiter. This planet has a tremendous gravitational pull. And unfortunately for a tiny comet like SW3, this comet occasionally would have encounters with Jupiter. It would pass close to it, and then Jupiter, with its big gravitational pull, would say, hey, wait a minute, where are you going? And would pull the comet off its course. Not a whole heck of a lot pulling off, but enough so that if astronomers thought that they had a fix on it, if astronomers thought that they had a good orbit for the comet to use to try to pick up the comet again when it passed near the sun, it became invalid because, again, because of the interaction of Jupiter pulling the comet off course, it put it on a different course, and so astronomers may have been pointing their telescope in one part of the sky, meanwhile the comet was somewhere else. And again, a very dim comet it was. SW3 is not the only comet, by the way, which has this problem with Jupiter. This is an orbit, a view of the solar system. The innermost circle or oval, that's Mercury. Venus, here's the Earth. This oval here is Mars, and this oval right here is Jupiter. And notice all of these orbits, these are orbits of comets, just like SW3. Some 400 tiny comets that have been captured by Jupiter and put in small orbits, generally between 6 and 12 years. And SW3 is a card-carrying member of this group. This is Jupiter's comet family. And indeed, there were many, many, many comets that have been caught by Jupiter and placed into smaller orbits between Mars and Jupiter. And that is, again, why the comet was missing in action for so long, because, again, it was Jupiter had changed its orbit on many occasions. Well, in 1990, the comet came within about 30 million miles of the Earth. It was the most favorable apparition of this comet for us since 1930, when the comet was discovered, 60 years earlier. So we got a good look at it. We got a good fix on its orbit. And from that orbit, we were able to discern that the comet had passed Jupiter many, many times in the past, and that's why we weren't able to see it. So that was it in the spring of 1990. And then in the fall of 1995, the comet was due to return. But now, here's where the story takes a big twist. What you're seeing there is not a big fence. That is the great Nankai radio telescope that's located on the grounds of Paris Observatory in France. And in 1995, September, with the Nankai telescope, they decided to point it or direct it toward Comet SW3, and lo and behold, they found something very interesting was happening to the comet. The gaseous emissions from that comet were increasing quite a bit. In fact, if you remember your high school chemistry, you may be aware of one of the chemicals here, the hydroxyl radical, which actually spiked in the fall of 1995 to a point almost like 1/10 that of Halley's Comet, a much larger comet. But this small, teeny comet suddenly was sending out gaseous emissions at a very rapid rate. But it was also getting brighter. The comet was getting much brighter, in fact, than it had been predicted. And at the Central Bureau for Astronomical Telegrams in Cambridge, Massachusetts, they put out in October a special circular regarding Comet SW3, Schwarzmann-Wachmann 3. And they let off, we call this an ephemeris, and it gives you the positions in the sky that you can plot on a star atlas, which shows you where the comet was going to be in the sky, where you can point your telescope to see it. But get this now, you really didn't need a telescope. In fact, the Bureau announced that they had received numerous reports from observers worldwide of independent discoveries of this comet, which has continued its remarkable outburst in brightness. Now, think about this for a moment. You have a nice big telescope. You go and out to some place where you could see a lot of stars in the sky. You're going to make it an all-nighter. You're going to spend your night under the sky and under the stars, and you've got your observing list planned as to what you're going to look at. Now the sky gets dark. And as you start looking around and getting acquainted and get your eyes adjusted, you look over into the western sky and you see a fuzzy blotch of light. And you look at it and you say, what is that? What is that up there? It almost looks like, can it be? And then you put your binoculars on it, and then you turn your telescope on it, and you say, oh my God, that's a comet. And then you start thinking to yourself, I don't remember reading in any of the astronomy magazines that a bright comet like this was going to be visible at this time of the year, at this time of the month. And then you open up your laptop computer and you start typing nervously, checking out other observing sites and other sites that tell you about comet. And there's nothing. There's no mention of a new bright comet. And then all of a sudden it hits you. Oh my goodness, I've discovered a comet. And you immediately send out an email to the Central Bureau in Cambridge, Massachusetts. Or maybe you make a phone call to the on-duty astronomer. Or maybe even, for goodness sake, you send a telegram. Yeah, they were still doing that back in 1995, saying, I discovered a comet, here's the location. But no, It's not a new comet. And they said countless numbers of people around the world did this. How many people is countless numbers? What is that defined as? More than a few. But now the big thing is, what is this? This was Comet SW3. Oh, no, it can't be SW3. You say, Comet SW3 at this moment in time is 122 million miles from the Earth. And, it's 65 years ago when it was discovered. It came within less than 6 million miles, and you still needed a telescope. You still needed, at the very least, a good pair of binoculars to pick it up. Here, the comet is 25 times further away from us, and there it is. You could see it without a telescope in the sky. In fact, one of the foremost comet hunters, someone who has discovered comets on his own in Australia, Terry Lovejoy, wrote, "It looked like a mini Halley. Its coma displayed a striking parabolic outline." In other words, an outline that resembled the shape of a parabola against the background stars. And its tail was so intense in its first half degree that the ghostly glow was evident even through horizon haze. In other words, even after the comet had dropped all the way down close to the horizon, where it's rather hazy most nights, he was still able to clearly see the first half degree of the tail. What is going on here? I mean, again, this comet now, October of 1995, is 400 or more times brighter than it's supposed to be. Well, comets do have outbursts from time to time in brightness, and they do get brighter than they're supposed to. Sometimes a crack or a fissure opens up, and some volatile material will spill out of that and make the comet appear a bit brighter than normal. But they also began to notice in October that the head of the comet looked kind of bloated. What was going on there? And in early December, poof! Not one, but four. Count them. Four separate nuclei. The comet had broken up into four separate pieces. And during all of this time, when it was putting out more gaseous emissions and suddenly becoming very bright, when it became very bright, that was a signal that there was a tremendous expulsion of dust occurring. Dust and particles spewing out, apparently, from the comet just before it cracked up into four pieces. Dust is what makes a comet bright. There are two types of comets, the gas comets and the dust comets. The gas comets shine by virtue of ultraviolet light from the sun, striking the gaseous components of the comet and making it glow as if it were made of phosphorescent paint. And it glows a dim bluish color. But when dust is involved, dust is a very good reflector of sunlight. It's the dusty comets that are the ones that put on an amazing display. Halley, for example, is a famous example of a very dusty comet. That's why Halley is so bright when it comes by every 75 years. So this comet suddenly spewing out all of this, it was like we cracked it open, and all of this material is suddenly now spilling out of the comet out into space. Well, here is a view of the comet when it came back in 2001. You see at least three fragments here, but the big excitement in 2006 was the fact that it was going to come very close, about as close as it did going back to 1930. 7.5 million miles that comet was going to come within our planet. And now we're not talking about just a comet, we're talking about a bunch of comets, or at least a bunch of pieces, so many of them by 2006 that we had to alphabetize them. Here would be, for example, fragment A, B, C, D, E, G, H, I, P, R, X. There were numerous pieces, and now this whole bunch of pieces was going to pass the Earth. We had two telescopes, space telescopes, orbiting the Earth, which would give us a great view of it. And here's the first view from the Hubble Space Telescope, which was launched in 1990. So we're honing in now on the comet. There are three of the fragments. There's fragment B, fragment G, fragment R, and now if we zoom in on one of the fragments, we find that the fragment itself is breaking apart into smaller and smaller pieces. Look, oh my goodness. So now we don't have just, 20 or 25 for each fragment. At least the bigger pieces, we're suddenly seeing fragments that are on their own, being broken off. And then after Hubble looked at it, the Spitzer Space Telescope, used its infrared camera to look at the comet. That's why the comet here, or comets, look red. But look at this. We have this one fragment, and 2, and 3, and 4, and a larger fragment here, 6, 7, 8, and 9. And notice that they are that all the fragments, all the pieces are lined up right along the path of the comet in space. And before everything was over, said and done, there were not 1, not 2, but 60 different pieces that have fragmented from the original one fragment, one piece of the comet back in 1995. It truly is disintegrating. Now here's the orbit of the comet. Again, it goes around the sun in 5.5 years. Right at this area right here, right over here, if Jupiter happens to be moving, here's Jupiter's orbit. If Jupiter happens to be anywhere in this vicinity when the comet is here, that's when Jupiter says, hey, come over here, and tugs and pulls the comet a bit off course. Here is our orbit. Here, the somewhat slightly darker oval. That's our orbit right there. But do you notice here? Here's the orbit of the comet. And as it comes sweeping down on its orbit, it passes the Earth's orbit and comes very, very close to intersecting the orbit of our Earth. Again, on that magic day, May 31st. So now, with the comet fragmenting, going to pieces, falling apart, if you will, the question is it possible that some of those pieces might inevitably or eventually intersect the Earth? And if so, that could mean possibly a new meteor shower. And this is not the first time. There has been a precedent. In 1800s, the early 1800s, Wilhelm von Biela discovered, another German astronomer, discovered a comet, and it was named Biela's Comet. And in 1842, the comet split. It didn't break into 4 pieces, it split into 2. And the split or twin comets were seen in 1846. And they were seen again when they came around the sun in 1852. Biela's comet had a period of approximately 6 years around the sun, similar to what we have with SW3. And the comet was seen again in 1852. Then we were looking for it in 1858. Nothing. Gone. Everybody looked for it, but we couldn't find it. And then in 1865, a very favorable apparition, a very favorable time to look for the comet, and again, it turned up unseen. So everybody said, well, the comet split in 2, and probably between 1852 and 1858, it probably just fell completely apart, disintegrated, and it doesn't exist anymore. And then on November 27th, 1872, the Earth crossed that path in its orbit around the sun, crossed the path in space of the now seemingly dead comet Biela. We had said, astronomers had said, that we'd never see hide nor hair of that comet again. But on that night, November 27th, 1872, looky what was seen in the sky. A spectacular display of shooting stars. And meteors fell that night. It depended upon, I guess, how dark your sky was and how quick your eye was. But there were reports of anywhere from 3,000 to 10,000 meteors an hour that night for a few hours. An amazing spectacle. And nobody expected this. Nobody knew this was going to happen. It just so happened that if you were in Europe that night and the sky was clear, you stepped outside looking up, and there you saw this magnificent display. In the aftermath, the astronomers, after doing their calculations, realized that what they were seeing was the pulverized remains of now dead Biela's comet. So now the question, with our orbit so close to the comet of SW3 and with SW3 falling apart, is it possible that we might see something like this sometime in the future? That would certainly be great, wouldn't it, to go outside and see a celestial pyrotechnics display like this. Actually, there was a case in 1930 where a Japanese astronomer made a prediction that we might see a meteor shower around the time when the comet was discovered and passing closest to the Earth. And in fact, one person said that he did see a meteor shower from this comet on June 9th and 10th, that night, the overnight hours. 60 to 70 shooting stars per hour was visible to this observer in Japan. Not the guy who predicted the meteor shower, but from somebody else. He was on duty at the Nissan Observatory in Japan. He said, I see 60 to 70 per hour that night. Well, hard for me, or I think a lot of people, to believe. First of all, the meteors were very faint. In fact, they were right at the threshold of visibility. If you're into astronomy, they were about magnitude 5. And again, if you're outside on a dark, clear night, the faintest stars that are visible to your eye are around magnitude 5. So they were very faint. But the observatory director said, this gentleman has very sensitive eyes. All right, I'm willing to believe that. Why I'm not willing to believe that he saw a meteor shower, though, is that this same person said he saw all these very faint meteors on the night of a full moon. And not only was there a full moon, but there was a ring or halo around the moon. So there was high clouds in the sky, a full moon which lit up the sky and literally squelched the light of all but the brightest of stars, and yet this one gentleman in Japan claimed he saw 60 to 70 meteors per hour. Big question mark about that. And he was the only one. No one else. They looked for the meteors in the United States, in England, other places around the world. Nobody saw it except this one person who claimed that he saw a meteor shower. So again, it's hard or difficult, at least for me and many others, to believe that there was such an observation that night. Now, comets are cosmic litter bugs. You must understand that when a comet gets close to the sun, the heat of the sun melts off the ices in the comet, and the ices in turn liberate or free tiny dust particles that are embedded in the snow and ice of the comet head. We call comets, in fact, dirty snowballs. And so as the comet rolls around the sun and moves along in its orbit, it releases this material behind it. And the Earth in its orbit interacts or intercepts these particles, and that creates the effect of shooting stars. Now, all of the ejected particles, regardless of size and unless perturbed, stay closely confined to the plane of the orbit of the comet until, at least in time, the stream degrades. In other words, year after year, century after century, millennia after millennia, these particles, which may be closely spaced together, become more and more dispersed, and soon, finally, you can't even find the comet dust moving around the sun in a specific orbit at all. These gravitational perturbations of the planets are a major factor in shifting and breaking up a meteor stream. Tracking all of these influences is what meteor shower forecasting is all about. Now, if I mention meteor shower, or if it's mentioned on the radio or in television, tonight there's going to be a meteor shower. Unfortunately, I think this is what the average person is thinking about. They're thinking about something like this. You remember this TV show back in the 1960s, Lost in Space? I said many times, this one TV show set back astronomy and astronomy knowledge 100 years. No, it is not like that. A meteor shower is not like that. Instead, in the case of most of the annual meteor showers that we hear about, the majority of the visible meteors are caused by much smaller particles. Particles generally ranging in size from small pebbles to sand grains and dust, and weigh less than 1 or 2 grams. But the question again, will we see a meteor shower from Comet SW3 because it's breaking up and the orbit comes close to the Earth? So in 2005, a very technical paper was written by 3 Canadian astronomers, Paul Weigert, Peter Brown, Helen Shins, and they enlisted the aid of this gentleman that you see here, Jeremy Vaubaillon from France. And this gentleman, Vaubaillon, Professor Vaubaillon, produced a sophisticated model for the formation and evolution of comet dust trails. For Comet SW3, numerical simulations were performed on a supercomputer using 2 million particle ejections from 1801, long before the comet was known. Remember, the comet was discovered in 1930, but just to be safe, Vaubaillon decided that he would do calculations going back before the comet was even discovered back to 1801 and forward in time to 2006. And using his computer, he assumed that the typical ejection velocity for a sand-sized particle off the comet nucleus was about 20 meters per second. He did the calculations, and then came the end result. At the end of the paper, it concluded that looking ahead at the future, no significant numbers of meteoroids released during the 1995 splitting of the comet head is expected to encounter the Earth in 2022. Oh, darn! You read that, you're hoping that there's going to be a great display of meteors and shooting stars this year, but then you read that was written by one of the foremost experts, Jeremy Vabalyon, on the possibility using his super computer animation that we might see a meteor shower, and he says, sorry folks, no, ain't happening. So forget about it. Well, anyway, I was, during the pandemic, where was none of us able to do anything and we were confined to our homes or whatever, I said, it might be interesting. Out of curiosity, I decided to model the meteoroid stream associated with the breakup of Comet SW3 on my own. And I used computer software as something known as an N-body integrator. So I took the orbital elements of the comet from 1995 when it broke up, and then I created 20 fragments, samples that would represent a meteoroid trail, a trail of debris following the comet through space. And then what I did was I moved all of those particles and the comet itself in time from 1995 all the way up to the present, to 2022. And here is the animation. This is what I came up with. You see here's the planet Mercury right here. Here's Venus. Here's our orbit, the Earth. You'll see that coming around in its orbits shortly. And right here, right over here, is the intersection between our orbit and the orbit of the comet. Now, if there's going to be a meteor shower this month, we would have to have the comet passing through this region of space with its trail of debris behind it at the same time that the Earth was in this vicinity too, so that we would interact with that material. So watch what happens. We're going to start the animation. Here we are. Here comes the Earth around in its orbit. Here we go. Now we're heading for that intersection point. Here it is. Here it comes. Boom! Right there. We're at the intersection. But wait a minute. Where's the comet? Where's the trail of debris along with it? It's nowhere to be found. Vabalyon was right. And sure enough, long after we have left that intersection point in August, the comet and its trail of debris will be moving through. But too late to create a meteor shower, just as Professor Vabalyon wrote. Bachagaloop! No meteor shower in 2022. Oof, terrible. But then I started thinking about things. I started thinking about the fact that this is not a normal case. When you normally predict a meteor shower from a comet, you assume the comet moves around the sun, and as it gets close to the sun, the debris comes off of the comet's nucleus, is blown back behind the comet head, and that's how you get a meteor shower. In the physical breakup of a comet nucleus, though, we just can't assume that its constituent particles are chiefly dust and sand and grain-sized. Indeed, I would assume, I think you would agree too, that if a comet is going to break up into several pieces, that those pieces are going to be a heck of a lot bigger than little pieces of sand and pebbles and dust grains. They are likely to be, large nugget-sized pebbles, even the size of walnuts or ping pong balls. So we're not dealing with small particles, we're dealing with bigger pieces now. And just how large particles are spatially distributed depends in part on the spin of the comet's nucleus and the locations of its outgassing materials and regions. As the nucleus is heated by sunlight, bits of dust and gas come loose and are spread outward. And the pressure of sunlight helps to force these particles back behind the comet. Now, it seems kind of weird, the idea that light has push or pressure might sound a little strange to you. I mean, after all, if you hold your hand up to near an electric lamp, or if you're out in the sunlight, you don't feel the light pressing on it. But nevertheless, light does have pressure. It's only noticeable when the light becomes extremely strong, as it is near the sun, and only affects very small particles like molecules of gas or dust or sand grains. This is called solar radiation pressure. Small particles are pushed away more rapidly by solar radiation pressure, and regardless of the direction that they leave the nucleus, this pressure of sunlight helps to force these little tiny dust particles to a position behind the comet. But take note of this: particles that are bigger than grains of sand are greatly unaffected by solar radiation pressure. If you have a piece of material from the comet that's the size of a nugget, that's the size of a ping pong ball or a walnut, or even larger than that, it's kind of like the big bad wolf, trying to blow the brick house down. The solar radiation can push and push and push, but those big pieces aren't going anywhere. And this is my argument. In a normal case, the smaller the particle, the more rapidly it can be ejected out into space from a comet. But big particles, big pieces move more slowly when they're ejected. The teeny particles move faster. But this is not a normal case. This was the breakup of a comet nucleus. And when SW3 fragmented, particles of all sizes were probably ejected at high speeds, even the big particles. And since solar radiation pressure has no effect on ejected particles larger than sand grains, there are likely to be large particles now sailing through space forward or out ahead of the comet. See? So instead of just trailing behind the comet, what I am suggesting is that there are pieces ahead of the comet as well, forward. Those are the big pieces, the kind that solar radiation has no effect on. So I went back to my animation, I went back to my computer, rewrote the program, but this time, instead of having the meteors or the meteoroid trails behind the comet, now I placed the debris in front of the comet. And with time, they stretched out. Now, the question, will they interact with the Earth in this particular case? We start the animation again. Here comes the Earth around in its orbit. But before we get a chance to get to the intersection point, look at this. Look, the comet and its trail of debris all arriving. And in this case, I found that in between sample 12 and 13, that's where the Earth was, right around the 28th of May of this year. So yes, if they're out in front of the comet, there will indeed be an interaction, an intersection. So then after I found that out, I took the comet samples 12 and 13, redid their orbits, figured out what kind of orbit they were moving around the sun, and then I put another 18 particles or samples in between those two. Now I have an example of a segment of the orbit of the comet and its debris. In other words, between those two samples, I put a whole bunch of other comets together so I could get an idea of how the Earth might interact with that section of the comet orbit and whether or not we would intersect with how many different particles or pieces. So here you go. Here's the Earth. Here's the intersection point, and there is that segment, those 20 samples, of which we ended up sampling or intersecting with 5 of the 20. So yes, we most definitely would appear to interact with the comet and its debris. I came up with May 29.74 UT. UT stands for Universal Time. I don't have the best of computers, though. I probably have something just like what all of you have. So I said there's a margin of error of about a day and a half. So sometime between the 28th and 31st, I think we're going to see some kind of a meteor shower. But is there any way to cut this down and get it a little bit more accurately? Well, after I did all of my calculations and animations and whatever, I went out and I wrote a paper. Yeah, again, we were in the pandemic. I had nothing better to do, so I spent about 10 or 11 months cobbling away and writing a 12-page dissertation on my findings and my thoughts about whether or not the comet could produce a meteor outburst. And it was published by the Journal of the Royal Astronomical Society of Canada, a very prestigious astronomical journal. That was read by people all around the world. And when you have a paper published in a journal like that, well, you get some reaction. And there was reaction from a couple of academicians, more than a couple, many academicians, but two teams who looked at this and decided that, hey, maybe this guy has a point here. And so in Germany, Hartwig Luthern, Rainier Alt, and Michael Jaeger. And in Japan, Shon Hori, Junichi Watanabe, and Makaya Sato came together. Well, they didn't come together, they remained independent of each other, did calculations, assuming again that the material, as I was suggesting in the paper, is moving forward of the comet, not behind, as is the case in most situations. I said, no, let's assume that this time the particles are ahead of the comet, moving ahead, not behind. It's funny, there was I don't know how many of you are a certain age, but back when they used to advertise cigarettes on television, many, many, many years ago, there was one cigarette, Winston, and you know what they used it for Winston? They said, Winston, with Winston cigarettes, it's what's up front that counts. In this particular situation, that's precisely what it is going on. It's what's up front that counts. It's what's up ahead of the comet, forward of the comet, that will allow us perhaps to see a meteor shower. And you know what? Both of these teams, the one in Germany and the one in Japan, they did their calculations and they came up with a time, this one, May 31st, 12:57 a.m. Eastern Daylight Time. Now these teams, especially I know Luthern and Sato, are top of the line calculators. These two guys know their stuff and they work with only the top software supercomputers. And these two teams came within 4 minutes of each other in getting this time. That would be the time when the Earth would pass closest to the middle of the comet debris trail. 12:57 a.m., May 31st. That's a Tuesday, the day after Memorial Day. So if you want to make a note of that, that would be the time when, if we have a meteor shower, the meteors would be most prolific, most noticeable. And I was so pleased to see that these two teams came up with this, based again upon, being the catalyst here of making this suggestion. But want to know what made me even more proud? This made me more proud, the proudest of all. Here is Jeremy Vaubaillon. You remember him, the French astronomer who in 2005, with his supercomputer and his animations that he ran, made the decision that no, we're not going to see a meteor shower in 2022. Well, Vaubaillon saw my paper, read it, and suddenly made a consideration that, well, that sounds interesting. Is it possible that perhaps the meteoroids could be ahead of the comet instead of trailing behind like I suggested in my original calculation? He did a new survey, a new study, a short study. And when he wrote it, it made me so happy, so very happy. He wrote, in 2021, Joe Rao published a study showing that if the meteoroids are ejected at a higher velocity, they will definitely cause a meteor outburst. Rao also explored the influence of the change of the comet's orbital elements. In this short study, we confirm Joe Rao's findings and go slightly further, exploring the conditions that make the shower possible, as well as the observation optimization. So, Professor Vaubaillon changed his mind as a result of my paper and said, yes, indeed, we confirm it is possible that we could have a meteor shower at the end of May in 2022. When I read this, I sent Professor Vaubaillon an email, and basically I said, merci beaucoup, thank you. It is so wonderful to have somebody, a top master scientist, look at your work and confirm and say, yes, this certainly can happen. That indeed, when the comet fragmented, and all of these tinier pieces fragmented with the comet, now going out into space, that a number of these are out ahead or forward of the comet, and that we could very well intercept them at the end of May of 2022. So we now know that a meteor shower is most definitely possible. But now the big question, just how many meteors are we going to see? Now, unfortunately, this is not an easy thing to answer. We've never intercepted or intersected this trail that was formed back in 1995. When we go through it in 2022, this will be the very first time that we have ever intercepted these particles. So how could we possibly tell how many we're going to see? It's almost like playing the game blind man's buff. What's going on? What will happen? Well, maybe we can calibrate an answer by calibrating or getting an answer from calibrating this with another time when we had another situation with meteors from this comet. In 2017, 5 years ago, at the end of May of 2017, the Earth passed close to a trail of debris that was shed by the comet back in 1941. Now, we didn't go through the sweet spot, so to speak. In other words, we didn't go through the area where most of the garbage, most of the debris happened to be. In fact, we were about 102,000 miles away from the center of that debris trail. And that far away, everybody said, well, we're not going to see anything. How can we see anything? We're not even going to go through the sweet spot. But you know what? On the night of the 30th and 31st of May, 2017, cameras for the all-sky meteor surveillance program in California did see 5 meteors per hour. 5 members of the comet not really the breakup. The comet didn't break up, but some of the teeny pieces that are normally shed by comets when they go near the sun. So we intercepted enough meteoroids to see 5 per hour in 2017. That was back 5 years ago when we interacted with the 1941 debris. But now it's 2022. In less than a couple of weeks, we're going to be going into interaction with the material that was shed or let loose after the comet broke into 4 pieces in 1995. We're going to come within 35,000 miles of the center of that trail. So that would indicate, at the very least, from a proportional or scalability argument compared to 2017, that we would see this year an hourly rate, or potential hourly rate, of 14 meteors per hour. Now, I don't know about you, but I don't think I would wake up or stay up late at night to see a meteor shower that's only going to provide me with 14 shooting stars per hour. What does that amount to? That means if I'm out there for a whole hour and 14 meteors arrive, that means I would be seeing a shooting star about once every 4 or 5 minutes. Well, yeah, that may be good for some, but I'd rather see something more interesting, more numerous than that. But 2 things we have to consider here. In 2017, when we saw 5 per hour, we were interacting with material, as I said, from 1941. That 1941 material traveled around the sun 14 times. So those meteoroids had dispersed quite a bit from the time that they left the nucleus of SW3 in 1941 until the time they reached us in 2017. This year, we will be encountering the material shed after the breakup of the comet in 1995. And that material has only traveled 5 times around the sun. So the debris will be much closer together. And look, this time around, we're going to go through the area where the meteoroid activity or the meteoroid debris is heaviest, where the concentration of material is heaviest. Now, how much more concentrated, how much more debris, how much more, if you'll pardon the expression, schmutz is there in 95 as opposed to the material that was shed in 1941? Is there, let's say 10 times more material in this space as opposed to what we encountered in 2017? Well, if it's 10 times more, 10 times 14 would give us what? It would give us 140. 140 shooting stars per hour. If this pans out, we would be seeing meteors flashing across our line of sight at the rate of 2 per minute. Now we're getting somewhere. Now we're getting to see a legitimate meteor display that will be not only interesting, but also downright entertaining. 140 per hour. That's better than the meteor shower that everybody looks forward to in August, the Perseid shower. I'm sure you've heard about that, the so-called Tears of St. Lawrence. Even better than the very best shower we have each year, the Geminids. They provide us with about 120 an hour. This is 140 per hour, for goodness sake. That's pretty darn good. Now, where does he come in to this picture? Where does he come into this story? This, of course, I'm sure all of you have at one time or another have seen this guy on your TV. This is Bob Ross, and he has a show on PBS called The Joy of Painting, and he likes painting scenes. He does artwork. He paints a masterpiece using his wet-on-wet technique in 30 minutes. He creates beautiful masterpieces, mostly of nature scenes. And he also has a very soothing voice. If you ever have insomnia and are having a problem going to sleep, listen to this guy. He'll put you down in 10 minutes. He has a very soft, type voice. We're going to do happy little scenes, happy little trees. So why am I bringing Bob Ross into play? Because if you've ever watched Bob Ross, usually halfway or 3/4 of the way through his show, he'll look at you with that little glint in his eye and a little smile, and he'll say, hey, let's get crazy. Let's get crazy. And within the final few minutes, he covers the canvas with trees and mountains and valleys and ponds and sunrises and something. I mean, yeah, he does get crazy. But I'm going to use that mantra now for the meteor shower. We considered just a few moments ago, what if the meteors that we encountered this year are 10 times more concentrated than what we saw in 2017? Why don't we go, it was a breakup of a comet. Why don't we go a little more than that? Let's get crazy. Let's consider maybe 100 times more concentrated than what we had in 2017. That's 14 times 100. That would mean a meteor rate of 1,400 meteors per hour. The official definition of a meteor storm, not a meteor shower, but a meteor storm, is 1,000 per hour. And 1,400 an hour would fall into the category of a meteor storm. 1,400 meteors per hour. What does that mean? That means that, well, meteors would be coming across your line of sight at the rate of about 20 to 25 per minute. That's about more meteors than I think any of you watching right now ever seen in your entire lifetime. And that certainly is something that needs to be considered in this particular case coming up at the end of May 31st. Now, this is an important diagram to look at. This is the motion of the Earth. The Earth is moving in this diagram from left to right across your line of sight. Now, this shows the Earth moving through space from left to right. Notice that the path of the Leonid meteors, you've heard of the Leonids, they come along in November. And every 33 years, the Leonids put on a very, very good display of many, many, many meteors an hour, sometimes even a meteor storm. But whether they're very few in number or whether there's a lot, one thing that I can guarantee you is that the Leonid meteors are always very bright. Why? Look, they're hitting the Earth in their orbit. They're moving around in the sun contrary to what the Earth is. The Earth is going this way from left to right. The Leonids are moving from right to left in this diagram. They're hitting the Earth head on at an ultra-fast speed through our atmosphere of 72 kilometers a second, and atmospheric friction releases the kinetic energy of the object in a short live flash of light. The energy released per gram of the meteoroid's weight far exceeds the energy efficiency of the most powerful man-made explosive. So, a Leonid the size of a pea can create a beautiful, brilliant, long-lasting incandescent trail in the sky. But now look at the meteors coming from SW3, the meteor shower that we're expecting later this month, on May 31st. They're moving with the Earth. They're moving in the same direction as the Earth. Only those particles then that can catch up to us in our orbit around the sun has a chance to create a visible streak. But when they do move through the atmosphere, they're only moving at 16 kilometers per second. The Leonids are hitting us at 45 kilometers a second. 45 kilometers, by the way, 72 kilometers per second is equivalent to 45 miles per second. Very fast. 16 kilometers per second for SW3. That's 10 miles a second. They're only moving about a quarter as fast. So a proportion of the meteors that occur on that night, May 31st, or that morning, I should say, of May 31st, may be very faint or not visible at all. So the key here is you got to get to a dark site. If you live in a place where there are a lot of bright lights, I'm sorry to say you may not see. We may see 1,000 or 2,000 meteors an hour, but guess what? If the lights are too bright, you're not going to see very many of those because, well, the light of the meteors are going to be too faint for you to see them. Even in 1872, with the B-lid, the meteor shower that came from that twin comet breakup in 1872, the meteors were described as slow, faint, and evanescent. What's evanescent? That's a 19th century word. I had to go to my dictionary to look it up. Evanescent, transitory, fleeting, vanishing. So indeed, even in 1872, these meteors were faint. And if you were living in a light polluted area, probably wouldn't have seen a very spectacular display. Have to be in a dark area to see them. But not all of them are going to be faint, as was the case in 1872. Some of them were much brighter. Some exceeded first magnitude, as bright as the brightest stars in the sky, often appearing red with trains of orange sparks, like this. So you will see a few bright ones, but maybe a good number of them will still be faint. About 10 years ago, a Canadian astronomer, his name is Pierre Martin, living in Bootland Farm, Ontario, said that he saw a meteoroid that may be related to Comet SW3. He said, I saw a single gorgeous meteor, magnitude -1. That was equal to the brightest star in the sky, Sirius, the dog star, golden yellow. And it left behind a thick wake, which hung in the sky for many, many seconds after the meteor itself disappeared. Might we, could we, may we see a few of these kind of meteors the night of May 31st? I think it's certainly possible that we just might see something like that in our sky. And the meteors, well, when the Japanese observers were looking in 1930 and saw that very faint display, he said he saw them coming from the constellation of Hercules near the star Tau, called them the Tau Herculids. But really, this new, never before seen shower is more likely to appear in the adjacent constellation of Boötes, the herdsman. And there is where the radiant is where the meteors will all appear to fan out from in the sky. Now, on this view of the Earth, this is for 1 a.m. Eastern Daylight Time, May 31st, when the shower is expected to be at its peak. If you were in Baja California, in Mexico, Mexico, the radiant would be directly over your head. Wow. You have to stare up and look, and the meteors apparently would be flying out from the overhead part of the sky. These circles that you see are the altitude of the radiant for different parts of the globe. 80 degrees high, 70, 60. Here in the tri-state area, we're between the 60 and the 50 degree line. So the radiant in our sky will be 55 degrees high at the peak of the shower. Well, you say, well, how high is that? I don't have a sextant. How am I going to judge how high 55 degrees is? Well, you do have a sextant. Your fist held at arm's length, the width of your fist held at arm's length is equivalent to 10 degrees. Make a fist. Put the bottom of your fist on the horizon. The top part of your fist is 10 degrees. So as this young lady is doing in this diagram, using your fist, this is 10 degrees. Here's 20, 30, 40, and then this young man here looking even higher, up to 55. So do it for yourself. When you go outside this evening, do it for yourself. Make a fist, put it on the horizon, and then go 5.5 fists up. My goodness, that's more than halfway up the sky. That's where the meteors are going to be coming from, more than halfway up. Halfway up from where, you say? Well, here's a star map. I know people, they look at something like this and they say, oh, I don't know. I don't know the constellations. I can't figure this out. This is there's so many people out there who are into astrology. They can name all of the 12 signs of the zodiac. Uh, Aries and Taurus and Gemini and Cancer. And yet, if I were to ask any of those people to go outside and actually physically look into the sky and find them, they wouldn't know where to look. They don't know anything about it. But indeed, there are zodiacal constellations here. There's Virgo, and here's Libra or Libra, Scorpius, the Scorpion, Sagittarius, here's Capricornus. But you don't need to know any constellation to look for the radiant point of where the meteors are going to come from. You found the Big Dipper, I'm sure. You've seen that many times in your lives. Well, at 1 a.m. on May 31st, the Big Dipper is going to be in the northwestern sky. Just look off to the northwest and find the 7 bright stars, 4 in the bowl, 3 in the handle, that make up the long handled pan of the Big Dipper. Now, extend an arc across the handle of the Dipper. Follow the arc of the handle. Follow the arc to Arcturus. Arcturus, one of the brightest and most colorful stars in the sky. And that bright orange yellow star is going to be about halfway up in the west. If you can find where west is, and if you don't know where west is, just watch the sunset some night. That's the direction of west. Well, at 1 a.m. on May 31st, Arcturus, one of the brightest stars and most colorful stars with that orange color, is going to be halfway up in the sky. And right next to Arcturus will be the apparent source of the meteor shower on May 31st. So how easy is that? But I'll tell you what, don't stare at Arcturus. Don't look in this area. What you should do is go into your attic or garage or shed or wherever you have that long beach chair, that long lawn chair that I'm sure many of you have. Get out that long lawn chair, set it up, lay down on it, and just look up. And if the meteor shower, if there is a red hot shower that night, you'll see meteors fanning out across all sections of the sky. And if you look carefully enough, they all will be emanating back to the region around Arcturus in the west. So that is the apparent source of meteors, and that's where you should look that night or early that morning, 1 a.m., May 31st, for the meteors. And by the way, we had a lunar eclipse the other night. Hope all of you had a chance to see it on Long Island. The total phase coming just before midnight, that came with a full moon. But the meteor shower is coming in about 2 weeks. So when the moon is in position 2 weeks from now, it's not going to be full. It's going to be new. It'll be a razor-thin sliver. See, when the moon is full, it brightens the sky up. It squelches the light of most of the stars except the very brightest. If these meteors are faint, you're not going to see anything with a full moon. I mentioned that earlier in the talk. But it won't be a full moon. It'll be a new moon. There won't be any moonlight to interfere. So you should have, if you can get far enough away from the bright lights, far enough so there are no bright lights and where you can see a lot of stars, and bring along that lawn chair, hopefully you'll be able to have a view of this meteor shower. Now, the disclaimer, as I'm about to end this discussion tonight of celestial streakers. And here is the disclaimer. I personally am excited to see what happens, though I have to admit I won't be holding my breath. Meteor showers are notoriously fickle, and it's possible, quite possible, that nothing at all will occur at the appointed time. That's happened before. It may very well happen again. But the fact that this is happening in the wake of a breakup of a comet, and that we're looking at particles that were shed not hundreds and thousands of years ago, but only 27 years ago, the young nature of that outburst material for SW3 makes it seem like a good bet for some sort of activity to appear. And even if you don't see anything, if you do get out to a place where you can see a lot of stars, well, isn't that a lovely consolation prize? How many times have you gone out to a place where there are lots and lots of stars visible, and you just get a chance to look up and lose yourself in the sky and lose yourself in the universe? So you see, even if you don't see many meteors or any meteors at all, you're not on the losing end. You've actually had a very nice view of a very nice backdrop. But if historical patterns are any guide, I will tell you now we're long overdue for an event such as this. Over the last couple of centuries, it seems that a new, strong meteor shower emerges seemingly from nowhere with some frequency. Particularly noteworthy is a meteor shower known as the Lyrid shower. They come every year in April, but they only produce like 5-10 meteors an hour at most. But for whatever reason, in 1803, we must have hit a clump of thickly clustered material because on that night, the church bells rang in Richmond, Virginia, awakening people, and they all ran outside, looked skyward. They saw a magnificent display of shooting stars, and they fell to their knees. They thought the world was coming to an end. Look in the sky, the stars are falling. And in 1872, in the wake of the breakup of Biela's comet, we already talked about this, another unexpected display of shooting stars appearing in the sky. One sad story. One of the most illustrious astronomers of France, Camille Flammarion, he was so famous that he received an invitation from the Pope, Pope Pius IX, to come and have an audience with him. And so Flammarion left his homeland of Paris, France, and traveled to Italy, to the Vatican, to meet with the Pope. And while he was there, he was also going to meet with his friend, Father Angelo Secchi, who was the head of the Vatican Observatory. And when he arrived in France, and of course there's no airlines that'll take you quickly to France to Italy, he had to take a long, arduous train trip. When he got there, he was kind of run down and kind of tired. He said, I got a long day tomorrow. I'm going to go out on my porch. I'm going to look at the sun setting in the west, which he did in the beautiful colors of orange and purple and gold. And after the sun went down, Flammarion went inside and went to bed. And he missed out on this unexpected, spectacular cascade of shooting stars in the wake of the breakup of Comet Biela in 1872. The next day, he dropped in to say hello to Father Secchi at the observatory, and Secchi told him what happened the previous night. Can you imagine what Flammarion, how he must have felt? And then he said to Father Secchi, well, how did you find out about it? And Father Secchi said, I was having my evening meal. And then there was a knock on the door, the observatory door. And Secchi went to the door and opened up, and there was a gentleman he never saw before. And he said to Father Secchi, excuse me, Monsignor. He says, you can perhaps tell me what is going on? And Secchi said, what would you like to know? He said, why are the stars falling out of their fixed places in the sky? What is going on? And Father Secchi stepped out and stepped in it. He saw this dramatic display of shooting stars, and over the next 3 or 4 hours, he was out there counting. He counted over 30,000 shooting stars, and Flammarion missed it because he went to bed. And if you think that made Flammarion sad, when he met with Pope Pius IX, when he had his audience, the first thing that Pope Pius said to him was, did you see the shower of Diana last night? Diana was the goddess of the sky. So the Pope saw it. Father Secchi saw it. Many people saw it, but Flammarion didn't because he didn't know. Surprise! It was a surprise, and it caught him off guard. And even in the 20th century, in 1933, there was a comet, Comet Giacobini-Zinner. We passed through the trail of that comet, and on the night of October the 9th, surprise! Not expecting it, but we had a meteor shower, a meteor storm that night. So many were seen, people in Portugal and Spain and Ireland falling to their knees saying, what is happening? Why are the stars falling? So you see, we have had surprise meteor showers in the past. We haven't had a surprise meteor shower pop up in quite a while. Well, now, if this happens, it's not a surprise. I've just told you that it may happen on May 31st at 1 in the morning. But we haven't had a surprise meteor shower pop up in quite a while. Maybe this is going to be the shot. I'm going to be outside watching that night. The question I now pose to all of you as we close out this discussion is, will you be out there too? So that is it. The night of the shooting stars. We'll hopefully see them. It might not happen, though. When we don't know. We're just going to have to wait, watch, and see. But now that the talk is done, I'll be very happy to take questions. If you want to unmute yourselves and have a question, I'll be very happy to try to answer them for you. And not just about the meteor shower, but astronomy, or even meteorology, because I am a meteorologist. Anything that you'd like to ask, I'll try my best to answer. Anybody out there have a question? Catherine, I'm not sure if you can unmute everybody, or if you can give them the ability to unmute themselves. But anybody have a question about this? I guess I covered everything, so much so that nobody has any questions about this. Personally, by the way, I'll tell you how much I believe we're going to see this. My wife and I, next Tuesday, we're going to fly out of New York, and we're going to stay at a home of a friend of mine who has discovered many comets. His name is Don Mackholz, and Don lives in Arizona, well off the beaten path. He said, okay, you come out and visit me, and we'll be happy to put you guys up here for a couple of nights around the time of the meteor shower. He said, I'll meet you at the exit on Route 93, and then you just follow me, the 18-mile dirt road leading to my home. And from where he is, there aren't any lights at all. It is dead black, so black that I am told that, according to Don, you have to hold your hand in front of your face, and you can hardly see your hand. And that's how dark and how many stars he has in the sky. So I'm ready. That if I'm willing to travel that far to try to see this meteor shower, that shows you how much I think we're going to at least have some kind of a meteor display that night of, or that morning of May 31st. So let's hope that the weather cooperates here in the east, and let's hope that nature is in a show-off mood that night for us to see this display of meteors, this display of shooting stars. No questions?
We had a few thank yous in the chat. I haven't seen any questions come through yet.
Okay, well, if that be the case, I guess I did a pretty darn good job in explaining all facets of this meteor shower, and I do hope that all of you found it interesting and maybe even a bit entertaining. And I hope that all of you, again, are out and about in the late night hours of the 30th into the morning of the 31st. I'd say try getting out there around, let's say 11 o'clock on the night of the 30th, or midnight on the night of the 30th into the morning of the 31st. And we'll see what happens. I see Stephen says, is it true that forecasting weather is any better now than the past? Well, Stephen, of course it is. Of course. Do you think that they were making 7-day or even 10-day weather forecasts a half a century ago, back in the 1960s? I mean, I remember when I was a kid watching Tex Antoine and Dr. Frank Field, and they never told me what it was going to be like 10 days from now. But now with computer technology and our technology, our modern technology, we have a very good idea of the weather, of what's going to happen a good number of days in advance. We can give a hint or a clue, for example, in the wintertime, of a prospective big snowfall, maybe 5 or 6 days out. Back in the day, when I was growing up, a lot of these snowstorms would catch a lot of the meteorologists and weather forecasters by surprise. I mean, sometimes I remember one particular snowstorm in 1978, it was supposed to be all rain. It ended up being snow, and we had about 20 inches of it the next morning. Too bad the weather forecast was calling for more rain than snow. The Lindsay snowstorm. Look this up on Wikipedia. Mayer-Lindsay snowstorm. It was a storm that hit in 1969 on a Sunday, and the forecast was snow changing to rain. It started snowing. It never changed to rain. It stayed snow. And New York remained unplowed for like almost a week, and Mayor Lindsay took the blame, or didn't want to take the blame, but that's what everybody said, that it was Mayor Lindsay's fault, and we know it today as the Lindsay snowstorm. Weather technology and forecasts are much better now than they were many years ago. Stephen, to everybody, is it advisable to use things like binoculars to view a potential meteor storm? Well, the binoculars are good if you happen to see a brilliant fireball meteor streak across the sky and leaves a trail hanging up behind it for several seconds or more. While you have those binoculars around your neck, use them. Look up in the sky and look at the trail that's still hanging there with the binoculars. Long after the trail has disappeared, it will still be visible in the binoculars. And what's more amazing, at the part of the atmosphere where the meteors are appearing, 40, 50, 60 miles high, The high level winds are blowing that trail and bending it into all different shapes. I've seen trails that were bent like a boomerang, if you will, over many, many seconds using binoculars, again, because of the high level winds. But don't use the binoculars. If you look constantly at the sky, you're going to be constricting your view to a very small area of the sky. The best way to look at a meteor shower or a meteor storm is to, just as I said, lie back, look up, and wait and look and watch for meteors that are streaking, again, from the radiation point in all different sectors of the sky. So that's the best way to observe a meteor shower, not necessarily with binoculars, but use your own two eyes and be out there and just keep an eye and see how many you can see. Okay, if that's it, then I'm going to wrap it up. I've been talking long enough, and Catherine, I thank you for inviting me to give this talk tonight to your patrons, and maybe I'll come back later in the year and we could talk about another facet of astronomy or meteorology. In December, I'll be talking about an interesting thing that maybe some of you may have thought about. I call it the Christmas star. Was the Star of Bethlehem a supernatural sign in the sky, or maybe can we explain it using a comet or a fireball meteor or a brand new star, a nova, or maybe a conjunction, a gathering of the planets in the sky? That's a Christmas show feature that will be offered at the end of this year when we start saying Merry Christmas to each other. And since Christmas seems to come earlier and earlier, you see the department stores already have the trees up in September. Any case, maybe later in the year, if you're interested, I'd be happy to come back and give that talk or any other talk as well. But I thank you very, very much for allowing me to give this talk about this Perspective Meteor Show tonight. Good luck to all, and hope you have a very nice evening.
Thank you.